Quentin Verspieren. I work at the European Space Agency, where I am in charge of the Protect Accelerator, which is a new initiative that we have created and that aims to accelerate the deployment and implementation of solutions to safeguard space and ground infrastructure from space hazards, such as space debris and space weather interferences. This panel is organized by ESA to discuss a topic of great importance, not only for us at ESA, but for the space sector as a whole. Space debris and how we can deal with space debris, how we can reach a situation in 10 years, in 15 years, hopefully the earliest the better, in which space missions do not leave debris in orbit. And this is why we have called this session Towards a Zero Debris Future, which we believe is a goal that we should all have in this room and in the space sector. So we will have a lot of great actors in this panel, all deeply committed to space safety and sustainability, not just in words, but also in action. We have first Pamela Melroy, NASA Deputy Administrator, Hiroshi Yamakawa, JAXA President, Sridhara Somanath, ISRO Chairman, Anu Ojha, UKSA International and ESA Director, Michael Nichols, SpaceX VP of Starlink Engineering, and Holger Krag, Head of the ESA Space Safety Program. Thank you very much for taking the time to join this panel. So I want to remind you that we will be taking questions from the audience using the Slido app. So please use this app and let us know of the questions you would like to ask to the panelists. Before we start, I would like to give the floor to Holger Krag to give us a few details about the situation of the space debris environment with a few slides. Holger, you have the floor.
Good afternoon, everyone, and thanks, Quentin, and thanks also for the co-panelists to allow me taking the floor, setting this scene a bit, ESA as organizer, on where we stand in the space environment of today. And if you look at that slide, every dot represents a piece of human remains, and I mean artificial remains, so remains of our space flight. These are the objects that have a minimum size of 1 meter or more. We're talking about roughly 8,000 pieces. I move further. What you see now are all objects above 10 centimeter size. So take your smartphone, this is the size and larger. These are the objects that we know they are there because we can see them from ground. We are doing efforts on ground to actually track them, and we know where they are, we know where they come from, and the best is we know where they will be in the future. And the kind of data that comes with them is absolutely indispensable for spaceflight. We're talking about 30,000 objects of that size. And we move on 1 centimeter and above. Now the size, the number of objects becomes 1 million. And of course, we can continue the game above 1 millimeter. We're talking about 150 million objects. Now you might ask, 1 millimeter, that's very small. Does it matter? Unfortunately, it does. What you see here is the equivalent energy of an object of just 1 centimeter, so a cherry hitting an aluminum block at orbital velocities. That's 25,000 kilometers in an hour. So the energy equivalent of that is a passenger car running against a wall. And then you can imagine what it means to a spacecraft. Being hit by 1 centimeter object means it's a total damage. It's a loss of a system. Also, energy equivalent to that would be an exploding hand grenade, and you can also imagine the outcome of that. So even small objects matters. And of course, it's not now that we discover this. Bright people and of all nations have come together already more than 20 years ago to formulate some technical guidelines. One of the groups is the Interagency Debris Coordination Committee. There's the United Nations Committee on Peaceful Use of Space, ISO, and many others to come forward with some mitigation concepts. And they are very simple to summarize. Do collision avoidance as long as the spacecraft is active. After the mission, passivate the spacecraft, get rid of all residual energy on board, batteries, tanks, and switch off the transmitters. And then last but not least, get out of heavily packed zones like the low Earth orbits or the geostationary orbit. In the geostationary orbit, you may move upwards into a graveyard orbit, and in the LEO, you should re-enter. And when you re-enter, make sure it's done in a safe way. This is, just in a few words, the concept of space debris mitigation that we have today. It sounds like the problem is solved, but I think otherwise we would not be here. It's not yet solved. This statistics, it's my last slide, shows the number or the share of spacecraft that try to implement what we call post-mission disposal. That means they do an attempt and a maneuver to leave space at the end of the mission, to make sure that the spacecraft re-enters and burns in the atmosphere. There's a positive trend. The green ones are the ones that are trying and succeeding, but you see we are by far not there, meaning 100% or not even 90% is what we would like to see are not achieved. And I think it's a good question to consider what could be the root cause for that and what can we do to improve it. And so much for the introduction. I hand it back to you.
Thank you very much, Holger. It's always really useful to start with a few facts and a description of the current situation to then think about what we want to do in the future. So I will start with the first question to all the panelists. Holger mentioned various international debris mitigation guidelines that are currently in place, but we also see that the space environment is dramatically changing, and changing at a pace that may lead us to think that these guidelines may not be commensurate to this evolution. What is your take on this? Do you think these guidelines are still adapted to this fast-changing environment? So who would like to start with this question? Mike?
Sure,
Please.
I'll go ahead. I mean, I think to start, I think that international guidelines are not keeping pace with innovation in the space industry, and I think that's quite clear. And I don't think that's too surprising given the pace of innovation that we're seeing in the space industry. As an example, at SpaceX on Starlink, we've launched something like a little over 5,000 satellites for Starlink. We have 2,900 of those now with laser terminals, and those are connected to the ground 99.9% of the time. To me, that is a paradigm-shifting opportunity for space sustainability, where you have real-time data from all spacecraft and can communicate to those spacecraft. So when we talk about 2030, what we expect, I think it's that type of thing. And our guidelines keeping pace with the innovation, I don't think so. So we need industry to be driving those forward.
Thank you very much. Do we have other comments? Yes.
I think I'll just add to that. I agree that I agree that it's innovation, but also just these mega constellations, right? So it's not just that, though. The whole volume of traffic has gone up so much with so many entrants into the space industry. So not only do we need to have compliance with some things that we've agreed on, but we should be talking about mitigation as well.
Indeed. Would anyone else like to add on? Yes, Chairman Sven.
So the most important aspect is that access to space has now become much more easier. That means the launch cost per kilogram of spacecraft to orbit has now become lesser. Now we are seeing the trend of that coming down. That means more and more players are going to come into this sector. They are going to launch more and more spacecraft and more into LEO than in the past. And it's natural that we are going to face this clutter or the traffic issue of the space, and it's a reality. We can't run away from the reality. One of the issues that the terminology used is the debris. I think we are not talking about debris alone. We are also talking about parallelly the active satellites, which are going to be in large numbers. That they are no longer debris; they are active ones. So the issue today is how to handle the active ones safely. And also minimize debris creation in the process of utilizing them. So First point is that they are bound to increase. There is no way that you can work out a plan to reduce that number of active spacecrafts. The only way that we can handle is through responsible behavior. There is nothing else possible. When you increase your traffic in the city, what else you do? You build better roads, you build stronger regulations, you observe them much more carefully, catch those who are erring, and then if you need to punish them, yes. And there is no better way. So I believe that what we need today is a stronger way of engaging with all those players who are going to put these satellites there and create a global agreement or a way to regulate. But regulation is something that none of us like. No, we all feel that we need to be doing on our own. But the moment will reach that you have no way to run it on your own. I think we have reached that level. The conscience of the entire general public should reach that level that it needs a regulation, like what we do in traffic management of the aircrafts. I think we have an example which is readily there, which shows you how to regulate the whole of the program, with everybody enjoying the benefit of it. I think the time has come, and whole of this should be not at looking at zero debris possibility. It is to work amongst that clutter that you see around. Of course, the ability to solve problems related to 1 centimeter debris, which are already there, there is no solution. I think even in the scientific, technical way, there are no solutions. In terms of observation, we need to increase the capability for smaller and smaller sizes. There is to be understood and brought into the analytical domain. Of course, some of them can be mitigated with a little bit of debris shielding and things like that. But largely, the issues related to small debris are unsolved. I think it continues to remain as a major threat for all of us. The only step there is, yes, how to not to create newer, smaller debris. This is the major topic which we can, of course, discuss further.
I just want to pile on a little bit for a moment and say that you talked about some of the technical challenges. We've kind of reserved ourselves to policy and regulations, but actually the ability to track smaller and smaller objects with higher levels of precision, and even to have persistent custody of everything that is in space, we should be seeing technical innovation in those areas, not just the ones that are creating debris problems, but to solve those problems as well.
Yes, you would like to.
Thank you. I hope what I want to say actually weaves together some of the perspectives that have been shared, starting with that very powerful data set that was shared from ESA in terms of debris. Just to set the context, 15 years ago, and I'm sure many other people in the audience will have had this experience, I remember teaching my undergraduate students about the Kessler syndrome, or and it was a theoretical abstraction, but that has now changed into a real potential threat. In fact, we're seeing evidence that in some orbital altitudes that we're starting to see this effect that will creep up, but it will creep up in an exponential curve. So I think to address the challenge, I think there are 4 parts to the challenge. The first one is technological. So in various of the domains that have been outlined, we have a number of methodologies at the early TRL levels that are being championed. In the case of the United Kingdom, we're looking at active debris removal, and other countries are also doing that. And it's all part of a holistic solution. But from that technological challenge, then comes the financial challenge, because if we're looking at TRL 1 to 3 demonstrator programs in one particular area and a multitude of these, how will these translate into a financially sustainable program, and who is going to give that stability? Will it be satellite operators? Will it be governments? I'm not saying I have the answers here, but this is part of what we need to think about. That then leads to the regulatory regime. Now, when it comes down to a regulatory regime, different countries will have different sort of launch regulations that may put the onus on a satellite operator. You can use a carrot approach, or you can use a stick approach. So one thing that the United Kingdom is doing with other countries is working through the United Nations to try to establish best standards of practice and expectation. And that finally leads us to societal expectations. Because when we look at this, we often look at this through the prism of us as a space sector. But we now have a society in which environmental protection is a fundamental parameter against which all of our interventions and our plans will be measured. And so I think if we are to have a fully sustainable solution to a really challenging problem, then we've got to look at all of those elements. We've got to look at the global activities that are going on and try to cohere them with I think, quite frankly, an increased sense of urgency, because this is I would argue, the most challenging issue we're facing as an industry.
Thank you very much. No, you're right, and you pointed out the perfect dimension of the problem. There are a few dimensions that needs to be tackled at the same time. I will give the floor to Professor Yamaka.
Well, I just would like to add one comment. Of course, zero debris is a very ideal situation, but in order to realize that, as everybody says, that we have to increase our observation capability or debris avoidance maneuver strategy or something like that. But at the same time, the balance between regulation and technology is very important. I mean, technology should be compatible or feasible in terms of regulation and vice versa. So that's another point I would like to mention.
Yes, Holger, you would like to add something?
I want to join my colleagues here that we have indeed two problems. And the technical problem is really apparent. I think today you find nobody that is ignorant about the problem. Everybody would like to make sure spacecraft are disposed, are passivated, and all the actions are taken, but it's just difficult to achieve it. It's difficult to achieve it technically after 10 years of operation, have the robustness and the redundancy on board to actually do it. So we need technology to help that. And I think agencies are in a good position to drive and put this technology forward. And then there's regulation. Today, we are asking 90% success rate for a disposal action. That means a dozen of objects may fail every year, and that would be totally okay. And there is something I think, which is not zero debris. This is something I think where we can also look into the regulatory side to bring some more ambitions on.
So let's talk concretely about these technologies and these policies that are necessary to drive change in space debris mitigation. And yes, of course, a global solution will be important, but it's also necessary and part of the responsibility of each major organization to also lead by example and to develop certain technologies, to develop certain good practices, to have an internal policy that is in phase with the importance of the topic. So I would like to ask each of you, in your respective organizations, are you envisioning a tightening or a strengthening of your debris mitigation requirements and policy? And how do you want to translate this vision into specific technologies? What technologies are you planning to prioritize? Yes, Chairman Somanat.
In India, in Indian Space Research Organization, we have taken it to ourselves as a policy that we will create a framework on which we will not add to debris. In many areas, we decided that in the launcher side, the upper stages of the rocket always become a spacecraft-like, and we make sure the stages are always passivated and no pressure and no explosives are left behind in them. And it is compulsorily done, even at the cost of the mission flexibility that you know. So we also did some of the orbits where we need to launch spacecrafts in very critical orbits, but we made sure those upper stages are brought back to much safer orbit to have a lesser residential lifetime in orbit. So that also we did as an additional mission measure. Wherever satellites are becoming defunct, we intentionally deorbited them. In the last year, we deorbited 3 of our satellites, which included one of the Earth observation satellite, Cartosat, one joint satellite, Megatropics, and one more. We intentionally deorbited to make sure that even the last of the life is better utilized in deorbiting than leaving it there for additional observations. We are also adding a capability to add a mathematical strength to our team to make sure our launchers and all conjunction analysis capability are built within the organization itself so as to handle all our spacecrafts and also work with other agencies across the world to make sure this data exchange analysis matches are well done. I think that a strong team has now come up in our organization to handle this mathematically, to give very good predictability of all such conjunction analysis based on observable data. In the long term, we look at how we can create more observational capability and technological capability to understand debris of smaller size, bigger size. Bigger is, of course, better possible, but for smaller, we need to create the technological capability, both based on terrestrial observation and space-based observation. We are also looking at robotic capability in the future to demonstrate the recovery of different satellites or refill and reuse. This becomes one of the major topics of our organization. Currently, we are discussing to make sure in the coming 1 or 2 years, we launch such a mission to make sure such capabilities, which includes autonomous robots, or tethered robots, which can go from our upper stage of the rocket and demonstrate a grabbing of a satellites to bring it back to the stage as a technology capability demonstration. Of course, deorbiting is a well-known phenomena and many companies are working on it. So we do not want to venture into that domain. But most of the important capability we would like to do in our organization is to stick to those principles. At least as an organization, we should not be, we should be an example by ourselves that we propagate the principles of not creating additional debris.
Thank you very much. Mike?
Yeah, so for SpaceX and for Starlink in particular, this is something we work every day, all the time. Quite frankly, we could not operate our constellation if we didn't make space sustainability one of our primary objectives. So it starts with how we design the spacecraft. We design them for reliability. We do accelerated stress testing on the ground before we launch, and then when we do launch, we launch low, and we launch low because if there is a failure, we can deorbit, and it will not create long-lasting debris. And then on station, in terms of operations, we're constantly lowering our maneuver risk thresholds all the time. So we're already maneuvering at a rate that's about 20 times more conservative than the industry standard. And one way to think about that is that our constellation has the same aggregate risk as a constellation that's a 20th of its size if it were operated at the industry standard. And we're not happy with that. We're continuously pushing the envelope. Pushing the envelope means investing in new technologies because it suddenly matters how good your atmospheric predictions are, how well you can predict where objects are, how well you can track objects. So it's about pushing the envelope all the time. Holger mentioned a 90% disposal success rate. That is nowhere near what we could target. And maybe when we had a few satellites that was, but now we're at 99% disposal success rate. And again, we're not happy with that. We have to push the envelope on that every day. We're doing things like what we call high drag deorbit. So from our operational altitude, it takes 3 to 5 years for a ballistic object to deorbit. We can actually maintain control authority and put the satellites in a high drag configuration and deorbit in under a year, and then do collision avoidance maneuvers using differential drag while we do that. So it's those types of things we're investing in and are really focused on in our organization.
Thank you very much. Holger, do you want to go next?
Yeah. I'm grateful to the ESA member states who have entrusted budgets into the space safety program. At about 250 million are associated to the space debris technology. So this is a massive boost for technology. And it starts out with deorbiting kits that you can mount on board before you launch that provide extra redundancy, extra propulsion for a space system that is completely failed in orbit to still dispose it. Then technology for automated passivation on board and other mitigation actions on board, and then active removal. So we are working on a mission that is called Clean Space One that will do a removal of an object from space. And also in-orbit servicing. In-orbit servicing means actually reusing objects that are already in space, which is also having a positive effect on sustainability.
Thank you very much. Deputy Mr. Mary, do you want to go next? Professor Yamakawa.
Well, yes. To realize zero debris, I think at least we have to decrease the number of the space debris positively. And that's why we are trying to engaging in active space debris, as I mentioned in the previous session. But according to our engineers' calculation, that at least we have to remove 5 or 6 huge, big space debris a year, which will realize not zero debris, but at least we can maintain the number of space debris. So that's why we're trying to solve that problem, or from a technical point of view, and that's why we're engaging in a kind of active space debris removal mission. And as I said in the previous mission, that the first approach is mainly devoted to RPO, rendezvous and proximity operation of non-cooperative target space debris. And that's very challenging, and as you can imagine, that because we don't know the exact attitude motion or spin rate or something like that of our target. So that's why we would like to launch this fiscal year of the phase one that is going to observe the target space debris. And as I said, the next step is to actually remove. And I said in the previous question that the regulation should be compatible with the technology standard or level. So at least we have to acquire that kind of technology, and then we can discuss the regulation. That's our approach.
Thank you very much. It's really impressive to see all these missions coming up for RPO and ADR. Yes, please.
Just an observation. I mean, this does tie in with anecdotal evidence that we picked up in the United Kingdom. I was delighted, and we've seen this, the deliberate decision by Starlink to be proactive in this way. And I think that is to be commended. I think the challenge going forwards, if we're looking at that massive LEO congestion that we have now, and which is forecast to get worse, I think the momentum space is going to be really, really pushing on the new mega constellation operators when we're going to be looking at Kuiper, when we'll be looking at, I think, the 13,000 satellites in the Guowan constellation. And so this is why, we have to have that marrying of the technological capability with a regulatory regime, but also, I think, more of the satellite operators realizing that it's in their financial sort of business model sustainability to be working in this way. So I just wanted to commend that approach. And, the ambition is that this will be adopted as a future norm. But I don't think we can afford to be complacent about this at all, which is why we need this multi-pronged approach.
Would you like to quickly respond back?
Yeah, could I jump in on that? Yeah, thank you. And I think one thing we haven't really talked about is the challenge of operator coordination, because we're investing in technology every day, but in fact, some of our biggest challenges are around coordinating with other satellites. And we're trying to lead by example there, share our ephemeris, the positions of our satellites publicly and in many, many different ways. Do things like take maneuver responsibility for other objects, but we need other operators to be engaged in that as well. And so when other operators are not sharing their ephemeris because of for whatever reason they view it as they're not generating ephemeris, they don't feel comfortable communicating those things publicly, it really creates a safety concern. And I think this is going to be the big safety concern that we face, is this coordination between operators.
Yes, so I do want to talk about what NASA is doing. We always try to focus on our mission first, which is that we are a science and technology organization. Having said that, we do think science and technology informs policy and should inform policy. And we're proud of the history of that because little less than 2 decades ago, our modeling team did some analysis. The space environment was quite a bit less complex then, but they came up with a handful of orbital debris mitigation standard practices that first were accepted by the federal government in the United States, then were incorporated into our regulatory regime and have now proliferated throughout the world. As we already addressed, that is not enough, and there's more to be done. So, we are staying current in this area. We issued a best practices for conjunction avoidance handbook that is available publicly, and we provide training and workshops on that. But really, I think we needed to take another step. So earlier this year, Bob Cabana, our associate administrator, who's the COO of NASA, and I chartered a space environmental sustainability advisory board to do two things. First, to oversee our own and look at our own practices to make sure that we were following all the best practices that we see and know about, and also to take a look at coming together with a strategy for how we could use our capabilities in science and technology to advance. And we do have, in fact, some interesting ideas. Maybe we can talk about that in the next question. But we are taking a proactive stance, and I hope to have that strategy out by the end of the year.
Thank you very much. So we have been talking a lot about the beginning about the importance of regulation, the importance also of a global solution. However, regulatory processes take time. I'm sure you're all very well aware of that, and in particular, international ones. So what value do you see in the meantime, even though we may envision the regulatory solution as the ideal, of seeing groups of proactive actors that try to lead by example, try to jointly develop new practices, new objectives, a new vision of space sustainability, and try to show that it is possible to go beyond the current status quo, the current consensus? Do you think this is enough? Do you think this is welcome? Do you think this is what we will see primarily in the future? I would like to have your thoughts on that. Mike, yes.
Yeah, I think on the industry side, I think absolutely. We need to be proactive and coordinate with other operators. We've in fact published a best practices document with OneWeb and Iridium that describes our blueprint for space safety that we're kind of revising continuously. So as we learn more, as other operators come into the dialogue and contribute their learnings, we can revise that. And some of the standards that Pam mentioned as well, I think are guidelines that we can use to educate the community, expect other operators to adopt, and then move the industry forward that way.
Yes.
Yeah, I just want to, the thing that is missing, I think, is we need to collectively transition from this being a nice to have issue to being a must have issue, because the sense of urgency is absolutely manifest on this. And when we're looking at, I mentioned about societal expectations on this, I think when we are, it's one of the biggest questions that I'm asked, is the public and increasingly policy makers outside our sector are asking, what are we doing about this? Are we doing this at scale and with the sense of urgency that we need? The issue we want to avoid, of course, is the analogy of the plastics in the oceans issue. And I think that while as individual agencies and individual companies, we are developing the technologies, influencing regulatory regimes, working towards best practice, I still feel, and this is personally, although it is translating into the way the agency in the United Kingdom is prioritizing this as being sort of right at the very top, I think we need, I won't say an order of magnitude increase in collective urgency in addressing this issue, but certainly half an order of magnitude. And so clearer communications with policymakers, clearer communications on the urgency issue within our sector to operators and to regulators, and also a clear prioritization to those wider companies that can help provide some of those engineering solutions that we need to go at pace and can help commercialize them so that it becomes sustainable.
Thank you, Holger. You wanted to add?
Yes, I think there's a very, very normal human reflex sometimes to say, I will not move before everybody moves, right? And that the lowest consensus level that we have is the international law of today. And we all know it moves only very slowly. And of course, we must stand on the ground of this law for sure. But I think when I showed these numbers to our ESA directors, they were saying, can't we lead by example? No matter what the current standards are, can't we go a step further? We don't want to see ESA missions contributing anymore in any way from 2030 onwards. You need to give it a bit of time for the technology to develop, meaning that such missions in the future would have to be built in a way that they can be disposed by all means. And if that fails, means like active removal would have to come in on top of that to fix the situation, meaning that a contract with such a provider would have to be demonstrated before launch, which makes a very interesting game change because suddenly you create a market for these kind of things. And you said something very important. You said technology informs policy, and I fully agree to that. No regulator will do such a move if that's not demonstrated. And who else can demonstrate it than agencies? So we are willing to really implement and try this for our missions from 2030. And yes, there's no guarantee that others can follow or will follow, but I'm convinced that at least some pragmatic actors must move forward in that way, and we are trying to embrace and invite them with an approach that we call the Zero Debris Charter, which invites all proactive actors to join us in an effort in defining such goals for ourselves, not to bypass any of the existing agreements, but to add an additional step onto it. So this is an open initiative for everybody to join the Zero Debris Charter.
Thank you very much, Holger, for mentioning this important initiative. Professor Yamakawa, would you like to add? Yes.
Just one thing, I just want to reiterate what Holger has just mentioned. I think space, I would say, space sustainability is a matter of, urgent. We have to tackle this problem urgently. It can be considered as a matter of security or safety, but as he said, we have to commercialize this activities in order to make it sustainable. That's what I want to say.
No, indeed, and I think that was an important part of what Holger mentioned. Counting on ADR in the future is counting on the fact that there will be a market for it. Does anyone want to comment on this effort on also working on, I would say, the economics of space sustainability? That is what in the end will drive us to a real transformation. Yes, please.
Well, I would like to highlight that we have a small think tank inside NASA, the Office of Technology Policy and Strategy, and they published a very interesting paper this year. They looked at the economics of debris remediation and compared it in terms of cost effectiveness, which is how much do satellite operators cost or charge, or what is their cost to address this risk? And they do a number of things. They'll call up a space situational awareness company if they get a conjunction assessment and get more precise data and decide if they have to make a maneuver or not. That would be one way that they would expend money on that. They have people who work on the issues. They have people who are consulting and working on the policy element. But in the end, it's actually kind of surprising. Our satellite operators are not spending that much money on this. It's a hand-wringing scenario. It's scary. The worst case scenario is just about impossible to ensure. And yet at the same time, because there's so little that can be done right now, they're not spending a lot of money. And so what we found is that the return on investment for some certain types of debris remediation, we're not sure if there is an actual return on investment. But I think I'd like to make a bigger point here, which is really, I'm going to give you a little commercial about our strategy, because when that came out, that really was an aha moment for me, and I started asking a lot more questions of our strategy team. And one of the things that they identified for me is that we lack a common framework for all the knobs that we can turn and which knobs have the biggest effect. And so I just want to say to everybody, we're all very worried about this. You in the audience are here because you're worried about it. We are all deeply worried about it too, for economic and reasons of allowing access to space and so forth. But it has been hard to know exactly what to do. I think certain models show us positive effects. President Yamakawa, you talked about one of them, which is removing a certain number of large objects. One of the challenges with all of those models is that the world is changing very quickly and the environment. And so what we think is we need to generate a model that allows us to see the interconnections. And I'll give you a few examples between, for example, like a low size weight and power capability to do an intentional deorbit for that's very easy to add to your satellite. But you also have to balance that with the societal benefits of the satellites that are operating and the value that they bring, the cost that you're using, and the risk. We don't even have a shared understanding of how much debris is okay versus not enough. If we had better space situational awareness, spacecraft could maneuver to avoid debris, but if we removed the small debris, we wouldn't need to track them or shield against them. So this is just a simple example. We really think we need to be working on a common framework and a model that allows us to see where we can have the most impact, and then we can coordinate both our policies but also our technology investments.
Thank you very much. Yes, Chairman Simonet, if you want to add.
Now, if you compare two sectors, two examples which have been brought here, one, of course, is related to the plastic pollution of the oceans. You seems to believe that it's not affecting us. Many of the people do not consider it as a greater risk because it's not evident in front of them. Though many people, scientists, speak about it as a major threat to the environment, it's not getting recognized as something that on which you need to have a global policy that need to be applied. Look at space now. Now, if you apply the same thing, it won't work there, that manner. Within very short violation, that whole space will become inaccessible to you. Not like that you can still sail on the sea, you can still continue to do fishing. It's no longer will be possible for you to explore space if you do not control beyond a point. So there is a threshold at which that you will be stopped physically from accessing space. And this is a very important message. Same is the case with the traffic. You look at cars that comes into our midst. It needs to go through certain certification process of every nation. I don't know the rigorous certification of every new space objects that goes to space is as strict as an automobile car. I do not know. I believe it is so. I think each of the nations who is actually authorizing the spacecraft that need to go up requires that type of rigor in the nation, at least to ensure that it meets certain global guidelines of safety, interoperability, safety for others. I think all these are important. I think these questions need to be asked. If you purely look at from economic perspective of minimizing debris, it won't work. I think there are for example, for new players, the question of debris will be a secondary question. Their first priority will be to somehow put it in space and demonstrate the technology for showcasing their business intent. And if it's shut down in the first instance itself on the first day, I think it becomes a debris for us. So it needs to be supported by governments to start with. I think without that, it won't take on beyond a point, because we need to understand it is a global issue. It cannot be purely looked at from a commercial perspective. Of course, commercial approaches for debris removal will become a very attractive option, provided the initial efforts and initial push is done by governments and public funding.
Thank you very much. I was told that we'll need to wrap up this panel, so I want to finish by going back to the title and asking you, I would say in an inspirational way, to answer the following question. What does a zero debris future mean to you? What is your vision of a zero debris future in 2030, in 2040? What is the space environment that you want to see at this time? Not everyone has to respond, but a couple of you who would like to. Yes, please.
Yeah, I mean, number one, just following on, I don't want to see it rendered in low Earth orbit particularly unusable, because space is part of our critical national and critical societal infrastructure. But number two, from zero debris comes space sustainability. And from space sustainability and space environmentalism, I think I'm going to throw another challenge in. We need to be looking at getting more data on the issues of increased launcher cadence and potential for stratospheric impacts, because Some of you will have seen the JGR modeling from last year, first level modeling, that this may be an issue that hitherto we've not worried about. And I think from an integrity point of view, if we're going to talk about this holistically, but starting here, then this is an area which needs to be explored and needs to be incorporated as rapidly as possible.
Thank you very much. So, Mike, for the closing?
Sure. Yeah, so what is zero debris? I think most importantly to me is that it doesn't mean zero action. Like I think that is one way to minimize your risk or make it go to zero, right? Spaceflight is inherently risky. The way to make that risk zero is just not to commercialize space or not to go, launch spacecraft into space. And humanity demands that we go do that. We must explore. So it's about actually minimizing those risks, controlling those risks, and understanding where they are. So I think zero debris to me in like 10, 20 years is a space environment where we've developed the technologies that enable the type of autonomy that we have on the ground because we're so connected to our space environment, and that we have broken down the walls of operational coordination that allow us to safely coordinate without borders as we explore the solar system.
Thank you very much. And Holger, you want one sentence?
I just promised one short sentence because for me it's a very simple formula. A zero debris future for me means we have a principle of that every national park has. What you bring in, you take out. And if that principle is applied in the future by whatever it means, I think we have a stable environment.
I could not think of a better way to end this panel. So thank you very much to all the panelists for this great discussion. Please join me in thanking them. Thanks a lot.